In this video, we're going to start talking about another type of conic section called the ellipse. So an ellipse is a set of coplanar points such that the sum of the distances from two given points, called the foci, which is the plural of focus, is constant. So with a parabola, we had one focus. With an ellipse, we're going to have two foci. Okay, so just like we did with the parabola, we're going to go through a few equations, which once we go through them, again, we'll take a more visual approach once we go through some examples. So the equation of an ellipse, there's one main form that helps you to find all of your information. And so this is the form we usually use. The variable a is the distance from the center to a major vertex. The variable b is going to be the distance from the center to a minor vertex. The variable c, which is not in the equation, but we can find it using a simple formula, is the distance from the center to a focus. Just like with the parabola, h is going to be the x-coordinate of the center. K is going to be the y-coordinate of the center. The center is the point hk. The foci are going to be at points of the form h, comma, k plus or minus c. The major axis will be of length 2a in the vertical direction, and the minor axis will be of length 2b in the horizontal direction. And the endpoints of the major axis will be h, k plus or minus a. And the endpoints of the minor axis will be h plus or minus b, comma k. And the distance between the foci will be 2 times c in the vertical direction. So all of that was probably a little confusing and a lot of information. But now, just like we did with the parabola, we're going to draw a little picture to tie it all together. So if we put down some coordinate axes, okay, the kind of ellipse that we're dealing with in this first column is the type where it's longer in the vertical direction than the horizontal. So major axis means longer axis, and minor axis means the shorter axis. So what we're looking at is some center, which we're going to label HK, all right? And we've got what we call vertices. We have 4 of them. So the major axis will be the longer of the axes. So we might have a vertex here, we might have a vertex down here, but they're going to be the same distance from the center in either direction. So let's say that those are our 2 major axis vertices. So the distance from the center to that vertex is going to be A. All right? Now the minor axis vertices will be a little bit closer to the center than the major axis vertices. If they were the same distance away, then we would have a circle. So a circle is like a special case of an ellipse. All right? So the distance from the center to one of those minor axis vertices will be B. And we're going to have some focus inside along the major axis from each major axis vertex. So the distance from the center to one of those focus points will be C. All right? And you notice if we connect all of these vertices together, we get this sort of oval looking shape. All right? So that's what an ellipse is. Okay? Now the column on the other side is going to be for an ellipse that's more oriented in the horizontal direction. So if we were to draw a picture for this, we would have the same idea going on. So we would have a center, which we'll call HK, but this time the major axis vertices would be along the horizontal axis. So let's say that those 2 points are our vertices, okay? We know we'll have 2 focus points somewhere in between there. So let's say they're right there. And then we'll have some minor axis points along the vertical axis, okay? So again, we have an ellipse, looks about like that, maybe. And this distance between the center and the focus will be C. The distance between the major axis vertex and the center will be A. And the distance between the center and the minor axis vertex will be B. Okay, so those are your two basic kinds of ellipse, and we'll go through and just do the formulas for the horizontal ellipse. Okay, so all of these things are the same, the variables, so I'll just write same for all of those. And so the center will still be HK, but in the case of the foci, this time we're changing the x coordinate. So we're going to add something to h. So instead of adding it to the y coordinate, we'll have h plus or minus c, comma k for our foci points. All right. The major axis this time will still be 2a in length, but this time it's in the horizontal direction. Okay. The minor axis will still be 2b, but this time it's in the vertical direction. The endpoints of the major axis will be h plus or minus a, comma k. The endpoints of the minor axis will be h, comma k plus or minus b, and the distance between the foci will still be 2c, but in the horizontal direction. Okay, so again, I know that that's a lot of formulas, but I think once we start doing examples, we'll be able to tie it all together. Okay, so just a few more things. I already said the major axis is the longer axis, so that's basically the direction in which your ellipse is oriented. So the minor axis is the shorter axis, which it's still important to a picture, but not so important when it comes to finding foci. We always take A to be greater than B. So your major axis is determined by which number in the denominator is larger. Okay? And the way that we find C is we use this relationship right here. Okay, so we know that B squared is equal to A squared minus C squared, or you could look at it as C squared is equal to A squared minus B squared. Okay, and so those are the same equation. All we did was rearrange it, and depending on what your problem looks like, some form could be more useful over another. Okay. The latus rectum, we usually don't talk about it too much with ellipses, but this is how you would find the length of that. And finally, the eccentricity, or basically how much, or how will I say this? How much like an oval your ellipse looks is what the eccentricity is. So a circle would have the least eccentricity possible. That would be 1. However, a very narrow ellipse, something like this, might have a very high eccentricity. Okay, so that's just basically how much unlike or how distorted is your circle in your ellipse. Okay, so hopefully that makes sense. So we'll move on to some examples now. Sorry if I overwhelmed you with some equations there. So let's look at example A. So we want to find the vertices, foci, eccentricity, major and minor axis lengths, and then finally we want to sketch the graph. So just like we did with parabolas, we're going to find all of this information, but we're going to start doing our sketch at the same time. Okay, so first of all, basically what you want to look at is first you want to determine your major axis. And here we notice that the denominator of 64 is bigger than the denominator of 49. So that's going to tell us that our ellipse is going to be oriented vertically. So we're going to get something that looks like that. Okay? Now our center is going to be 0, 0 because notice I have nothing added or subtracted from x and nothing added or subtracted from y. Okay? So my center is 0, 0. Okay? Now my major axis, we already said, is along the y-axis, and it's going to be of length 16. Okay? So let's think about this. So the square root of 64 is 8. So a is equal to 8. And so if a is equal to 8, then the major axis will be twice that, so it will be 16. So at this point, let's start drawing our picture. Okay? So we know that our major axis is the y-axis, right? And we know that we want to go 8 in each direction from the center. So this is the center, okay? And I want to go 8 units in each direction from the center in the vertical direction. So I get the point 0, 8, and I also get the point 0, -8. Okay, so those 2 points define my major axis, and now it's probably a little more evident why the length of that is 16. All right, for the minor axis, we look at the other denominator. So whichever number is smaller is going to determine our minor axis. So if we look at 49, the square root of 49 is 7. So b is going to be equal to 7. So the minor axis length will then be 14 because we want to do 7 times 2. So from the center, we'll plot 7 units to the left and 7 units to the right. Okay, so at this point, we have the point -7, 0, and on the right side, we have the point 7, 0. All right, so at this point, we have all 4 of our vertices. Okay, and so let's go ahead and list these. So our vertices, which we got from our picture, are as follows. We have 0, 8, 0, -8, -7, 0, and 7, 0. Okay, those are our 4 vertices. So now the last thing is just to find the focus, or the foci, and the eccentricity. Okay, so to find the foci, first we need the distance from the center to the foci, which will be that variable c. So we know that c squared is equal to a squared minus b squared. Okay, if we sub in a and b, we get 8 squared minus 7 squared is equal to 64 minus 49, which gives us 15. So c is going to be plus or minus the square root of 15. Okay, so what this tells us is that along our major axis, we need to go square root of 15 up and square root of 15 down from the center to get our 2 foci points. Okay, so the square root of 15, if you want to get a rough estimate, it's going to be somewhere between 3 and 4 because 15 is between 9 and 16, but it's going to be a little closer to 4. So we want to have our foci points about halfway between our center and our vertices in the vertical direction. Okay, and because these points are not nice integers, really make sure you're labeling them, or like I said in the previous video, if you're labeling things with letters, make sure to at least label the letter with the correct point off to the side, okay, if you don't want your picture to look too crowded. So I think that's what I'm going to do. So I'm going to call this point F1 and this point F2, but off to the side I'm going to say that F1 is the point 0 square root of 15, and F2 is 0 negative square root of 15. Okay, so those are my 2 foci, and now I really have everything I need to complete my picture. I just need to complete my shape. Okay, so if we connect those vertices, we get a pretty nice looking ellipse. Okay, and so the last thing we need to find is the eccentricity. So the eccentricity is c over a, which we found c to be the square root of 15, and we know that a is 8. So that's all there is to the eccentricity. Okay, so I'm just going to box in all of the things that actually were answers just so that you can see what was really important and what wasn't necessarily important. But keep in mind that I will want to see your work for finding that c variable over here. Okay, so that's our first example. So let's move on to the next one. So this time we have the equation 4x squared plus 25y squared is equal to 1. Okay, now the first thing you should notice about this is that we don't have any denominators. Okay, and that's a problem. With ellipses, we always want to match up our equation to that standard form where we have something in the denominator that's not 1. Okay, so if we think about this, this is the same thing as x squared divided by 1/4 plus y squared divided by 1/25 is equal to 1. So this time the a and b that we're dealing with are going to be fractions. Okay? And now, the first thing you should notice is what is the orientation of your ellipse. So if you notice, the bigger number is underneath x, that's the 1/4. 1/4 is larger than 1/25. So this is going to be a horizontal ellipse. So it's going to look something like that. Okay? So again, your center is going to be 0, 0 because we have nothing added or subtracted from x or y. Okay? So let's go ahead and pick out A and B. A is going to be the square root of 1/4, which is 1/2, and B is going to be the square root of 1/25, which is 1/5. Okay, so we found A and B, so let's go ahead and start graphing this ellipse. Okay, so I'm going to make the x-axis a bit longer this time because I know it has that horizontal angle to it. Okay, so let's go ahead and graph our center. So that's C. And I know that I'm going to go 1/2 to the left because now we have our major axis is in the horizontal direction. So this point will be -1/2, comma 0. The point to the right will be 1/2, 0. Going up, we need to go up a distance of 1/5. So this point will be 0, 1/5. And going down, this point will be 0, -1/5. Okay, so those are our 4 vertices. So let's go ahead and write those down. So we have 0, 1/5, 0, -1/5, -1/2, 0, and 1/2, 0. Okay, so those are our vertices. So now that we have the vertices down and we know A and B, let's go ahead and find the lengths of our axes. So the major axis, again, is the horizontal axis, and this is going to be 2 times 1/2. So the major axis length is 2 times 1/2, which is just 1. So that's the major axis. The minor axis length will be 2 times 1/5, which is 2/5. All right, so we've got the vertices, the axes, lengths. Let's see what else we need. We need the foci. So let's go ahead and find our distance C. So we know that C squared is equal to A squared minus B squared. And A is 1/2, so 1/2 squared minus 1/5 squared is 1/4 minus 1/25, which if we get common denominators, we're going to get 25 over 100 minus 4 over 100, which gives us 21 over 100. And so we get that C is the square root of 21 over 10. Okay, so our focus points then are going to be somewhere in between 1/2 and -1/2, and you can get a decimal approximation to get a better sketch. Okay, so I'm going to label this point F1 and this point F2, but I'm going to go off to the side and actually tell you what those points are. So the point F1 is going to be the point -√21 over 10, 0, and F2 will be square root of 21 over 10, 0. Okay, so those are my 2 foci. And the last thing that I want to find is the eccentricity. So the eccentricity, again, is just C over A. So I found C to be the square root of 21 over 10, and I found A to be 1/2. So if I divide these fractions, I get the square root of 21 over 10 times 2, which gives me the square root of 21 over 5. Okay, so that is the last thing I needed to find, my eccentricity. And now I just need to connect all of the dots in my picture. So if we connect the vertices, we again get a nice looking ellipse in the horizontal direction, and so that is your picture. All right? So let's try a few more examples. So just like we did with parabolas, we started with being given an equation and having to draw a picture, but now what we're going to do is, given some information, let's find the equation. Okay? So just like with parabolas, I would start by drawing a picture with all of your given information, okay, and then try to figure out what you need, all right? So in the first one, we're given that the foci are 5, 0, and negative 5, 0, and the vertices are 13, 0, and negative 13, 0, okay? So let's go ahead and draw a picture. Okay, so vertex 1 might be somewhere over here, and that's 13, 0. The other vertex might be somewhere over here, that's negative 13, 0. And our foci, we notice, lie on that same horizontal axis. So we have negative 5, 0, and 5, 0. So if you notice, we know now that our horizontal axis is the major axis because that is the axis on which our foci lie. So we know that the letter A must be 13 and it's related to the x-axis, okay? And I say that because that's how I remember how to write these equations down, is you basically just match the number with the axis that it belongs to, okay? So we know that C then is equal to 5 because that's the distance between our center, which we're assuming is 0, 0 for this part of the lesson, and our vertex, okay? Sorry, C is the distance between the center and the focus, okay? So we need to find B. So we know that B squared is equal to A squared minus C squared, which is 169 minus 25, which is 144. So B must be equal to 12. Okay, so now that I've found B, I know that B must be related to the y-axis. Okay, so now I really have everything I need to write my equation. So the general form of an ellipse centered at 0, 0 is going to be x squared over 13 squared plus y squared over 12 squared is equal to 1. Okay, so notice I just took that A and B and I matched them up with their respective axes. Okay, so the last thing we need to do is just simplify those exponents. So our equation is x squared over 169 plus y squared over 144 is equal to 1. All right, so that is the equation of our ellipse. Okay, let's look at the next example. So we have the length of the major axis is 8, the length of the minor axis is 5, and the foci are on the x-axis. So once again, let's draw a picture. Alright, so we know that the length of the major axis is 8. So that means that if our center is 0, 0, which again we're assuming that for this part, we would have to go 4 in one direction and 4 in the other direction. Okay, and since the foci are on the x-axis, we know then that our major axis must be the x-axis. Okay, so we have 4, 0, and we have negative 4, 0. Okay, so this means that A is equal to 4. The length of the minor axis is 5, so we must go 5 over 2 in the upward direction. So we have 0, 5 over 2. And we have to do the same in the negative direction. So our other vertex will be 0, negative 5 over 2. Okay? So B must be equal to 5 over 2. So now that we have A and B, we don't really care where the foci are. All we care is that they're on the x-axis. So we know that 4 must be related to x, and 5 over 2 then must be related to y from our picture as well. Okay, so let's plug this into our general formula. So we get x squared over 4 squared plus y squared over 5 halves squared is equal to 1. Okay, so that's our general formula. Once again, we just matched up a and b with their respective variable x and y, and now all we have to do is simplify the exponents. So we get x squared over 16 plus y squared over 25 over 4 is equal to 1. Okay, so it's okay to have a fraction in the denominator of your equation. I would rather see that than you then try to divide the fraction. Okay, so you can just leave it like this with the 25 over 4 in the denominator. That's perfectly fine. So this is the equation of our ellipse. All right, we have one more example for this video, and then in the next video we'll discuss the hyperbola. So finally, we have the length of the major axis is 4, the foci are on the y-axis, and the eccentricity is √3 over 2. So first of all, let's draw a picture. So we know our foci are on the y-axis. So our major axis must be in the vertical direction, okay? And again, our center is 0, 0. So if the length of the major axis is 4, then we must go up 2 and down 2 to get our vertices. So we have 0, 2, and 0, -2. So we know that A is going to be equal to 2, but this time it's related to the y-axis. Okay? Now, we're also given that the eccentricity is √3 over 2. And we need to find b in this case, because to write the equation of our ellipse, we're going to need that variable b. So let's see what the eccentricity gives us. So eccentricity is equal to c over a, which is equal to √3 over 2. Okay, well this is good. So we know a, we know that a is 2, so we have c over 2 is equal to √3 over 2. So then this will give us the variable c, which just by equating the two fractions here, you can see that c is going to be equal to √3. Okay, so we know our variable c, so now we can find our variable b. So b squared is equal to a squared minus c squared, and we know that a is 2. So we have 2 squared minus, we know c is √3, so we have √3 squared, and that's going to be 4 minus 3, which is 1. Okay, so we know that b is 1. So now we have enough to write our equation. So this time we're going to have x squared. We know that 1 then is related to x because 2 is related to y. So we have x squared over 1 squared plus y squared over 2 squared is equal to 1. So again, all we have to do now is simplify the exponents. So we get x squared over 1 plus y squared over 4 is equal to 1. And so again, even though you have 1 in the denominator of x squared, I would rather you leave the 1 there so that I can tell you know what the general form of an ellipse is. Okay, so that's a good start to ellipses. Keep working on the homework. It's at the end of the section. And yeah, we'll talk about the hyperbola next time.